Welcome to the Authentication Security Lab Series Part 2. In this video, we will learn why storing password in plain text is dangerous and how hashing algorithms help protect user credentials. Suppose a user creates an account on your application. During registration, their email and password are stored directly in the database as plain text. At first, this might seem simple, but it introduces a serious security risk. If an attacker gains access to your database through a data breach, they can immediately seize the passwords of all the users. Since many people reuse the same password across multiple websites, those stolen credentials can be public on internet and can be used to access other applications such as email accounts, social media platforms, or online banking services. In other words, a single database breach can put not only your application at risk but also many other accounts belonging to your users. This is why storing passwords in plain text is considered one of the most dangerous mistakes in authentication systems. In our demo application, we intentionally have the same security issue. When a user sends a sign-up API request, their password is stored directly in the database as a plain text. You can verify this behavior yourself by cloning the project repository from the GitHub repo link in the description. Once you have cloned this project, navigate to the project folder, run the npm install command in your terminal to download all the required dependencies. After the installation is complete, run npm start to launch the application on your local machine. Now the backend server is running. We can interact it using a Postman tool. To create a new account, send a post request to the API/o/signup endpoint on your local server. Let's send this request. As you can see, the request was successful and a new user account has been created. Now let's inspect our SQLite database and see how the user record is stored. Notice that the password is stored exactly as the user entered it. There is no hashing or additional protection applied to the password before it is saved in the database. This setup is intentionally vulnerable for educational purposes. It helps us understand why storing password in plain text is dangerous and what could happen if an attacker gains access to the database. Now let's understand how can we solve this problem. Instead of storing password directly in the database, we can use a technique called hashing. So what is hashing? Hashing is the process of taking an input such as password and passing it through a mathematical algorithm to produce a fixed length output known as hash. The important thing to understand is that hashing is a one-way operation. You can generate a hash from a piece of data such as password, but you cannot take the hash and convert it back into the original data. For example, if my password 123 convert into the hash, you cannot retrieve the original text from this hash. In other words, even a hash is publicly visible, there is no algorithmic way to reverse it and recover the original password. Another important property of hashing is that the same input always produces the same output. If you pass the same password through the same hashing algorithm multiple times, it will generate the same hash each time. So let's understand how this method allows us to verify password without ever storing them directly in the database. So when a new user registers or sign up into our application, instead of storing their password as plain text in the database, we first pass this password through a hashing algorithm on the backend server. The hashing algorithm converts the password into hash value, and it is this hash that gets stored in the database rather than the original password. As a result, the database never stores the user's actual password, only that hashed version is saved. This means that when a new user signs up, no plain text password record is ever created in the database. Even if someone gains access to the database, they will only see the hashed value instead of the user's real password. So now the question is, how does a user prove their identity using a plain text password during login if the database does not store the original password? Let's understand the process. When a user attempts to log in, the plain text password they entered during the login form is sent to the backend server. The server then passes that password through the same hashing algorithm that we used when the user is signed up. If the user enters the same password they used during the registration, the hashing algorithm will produce the same hash value that was originally generated and stored in the database. The server then compares the newly generated hash during the login procedure with the hash stored in the database generated during the sign-up procedure. If the two hashes match, we know that the user entered the correct password and can be authenticated successfully. If the hashes do not match, it means the password is incorrect and login request is rejected. The key advantage of this approach is that we never need to store or retrieve the user actual password. Authentication is performed entirely by comparing hashes. As a result, even if an attacker gains access to the database records, they will not see user real passwords. Instead, they will only see hashed values, which provide significantly better protection than storing password in plain text. So how can we implement password hashing in our project? Before seeing the implementation, it's important to understand that there are multiple hashing algorithms available. However, not all of them are suitable for storing passwords. Algorithms such as MD5 and SHA-1 are insecure for password storage because they are designed to be very fast, making it easy for attackers to perform brute force and distributed attacks. For password storage, we should use algorithms that are specifically designed for hashing passwords. These algorithms are intentionally slow and computationally expensive, making it much harder for attackers to crack stolen password hashes. Two of the most popular choices today are bcrypt and Argon2. In the Node.js ecosystem, bcrypt has been the most widely used password hashing algorithm for many years and is supported by a large community. Argon2 is a newly alternative that has been gaining popularity and is considered a strong modern choice for password hashing. For this project, we will use bcrypt because it is better tested, easy to integrate, and commonly found in real-world Node.js applications. Let's see how can we use bcrypt to securely hash passwords before storing them in our database. For the password hashing implementation, I have created a separate branch called SecureAuth. Switch to that branch and you will find the updated implementation with password hashing enabled. Now let's look at the code. To perform password hashing, we are using the bcrypt library. This is our signup controller function, which handles requests to the API/auth/signup endpoint. When this function receives the email and password from the request body, it first passes the password through the bcrypt hashing algorithm. This generates a secure password hash. If we look at the database query, you can see that we are inserting the email, the hash password rather than the plain text password. As a result, the user actual password is never stored in the database, significantly reducing the impact of data breach. Now let's see how we verify a user when they try to log in. If we look at our login controller function, we can see that when a user sends their email and password to the login API endpoint, the first step is to retrieve the user record from the database using their email address. Once we have the user record, we get the password hash that was stored during the sign-up process. Next, instead of hashing the password ourselves and comparing the hashes directly, we use bcrypt comparison function. Bcrypt takes the password entered by the user and compare it against the store hash. Behind the scenes, bcrypt performs all the necessary hashing and verification steps and returns either true or false. If the comparison succeeds, it means that the user entered the correct password and we can authenticate them successfully. If the comparison fails, it means the password is incorrect and the login password is rejected. This allows us to verify a user password without ever storing or accessing the original plain text password, making the authentication process much more secure. Now let's run the server and test our implementation using Postman. First, we will create a new user by sending a request to the signup endpoint. As you can see, the request is successful and the user account is created. Now let's inspect our SQLite database. Notice that the password is no longer stored in the plain text. Instead, the database contains a bcrypt hash of the password. This means that even someone gain access to the database, they will not immediately know the user's actual password. Next, let's test the login functionality. We will start by sending a login request with an incorrect password. As expected, the request fails because the password do not match the hash stored in the database. Now let's try again using the correct password that was originally used during the sign-up. This time the request succeeds because bcrypt is able to verify the password entered by the user and matches the stored password hash. This demonstrates how password hashing allows us to securely authenticate users without ever storing their actual password in the database. So that's how password hashing works. Instead of storing plain text in the database, we store password hashes and use them to verify securely during the login. If you found this video helpful, do not forget to subscribe for more authentication and security content. Thanks for watching.